The second method that we use in the determination of the valency is where we check on the electronic arrangement or the electronic configuration that is provided in the questions. So make sure that you're writing. So, and to begin with, we shall have the group 1 elements with their electronic configuration, and then I guide you on how you determine the valency of each and every element. So group 1 elements, we have lithium with atomic number 3, electronic arrangement of 2.1. We check on the last part here. This is the outermost energy level, meaning being a group 1, it will be losing only 1 electron, and so the valency is 1. We go to sodium, atomic number 11, 2.8.1 is the electronic arrangement. Again, it will be losing 1 electron, so valence 1. Next is potassium, atomic number 19, 2.8.8.1, again valency 1. Let me write the word valency in full. Then we go to group 2 because we are determining the valency of the first 20 elements in the periodic table. To begin with, we have beryllium, atomic number 4, electronic arrangement of 2.2. This one also is a metal. It will be reacting by losing these 2 electrons, so it also has valency 2. Then next we have magnesium, atomic number 12, and 2.8.2 is the electronic arrangement, so it will be losing 2 electrons in the outermost energy level, so again valency 2. Next is calcium, atomic number 20 with 2.8.8.2, so again the outermost energy level has 2. These are the electrons that it should be losing, so valency 2. So in other words, we can have a conclusion that these ones, being the alkali metals, they all has valency of 1. So now that they all are losing 1 electron. Group 2, being the alkaline earth metals, they all have a valency of 2. They are the alkaline earth metals. So that is very, very important for you. From there we have group 3 elements, the likes of boron, atomic number 5 with 2.3. So we'll be losing these 3 electrons from the outermost energy level, so valency 3. Next we have aluminium. Remember how to write a small l. Then it has atomic number 13, electronic arrangement of 2.8.3. Again, we'll be losing 3 electrons, so valency 3. These 3 groups, in conclusion, group 1, group 2, group 3, elements, they are all metals, because it is very easy for the three groups to lose electrons from the outermost energy level. Like this one has only one. Other than gaining 7 to achieve stability of 8 that we called octet the other day, other than gaining the 7 to attain 8, that is an octet configuration, these group 1 metals opt to lose the 1 electron from the outermost energy level, because they use retro energy to lose the 1 electron from the outermost energy level other than gaining 7. When you go to group 2, it is very easy, and they use retro energy to lose these 2 other than gain 6. Group 3, they use retro energy to lose the 3 electrons from the outermost energy level other than gain 5. So, and when the 3 groups lose the electrons from the outermost energy level, they become stable. And that is when we said that after they lose, they now acquire the ionic configuration with a positive charge. I just want to remind you that when lithium loses this 1 electron, it will become lithium ion, and the ionic configuration will then become just 2 after it loses this 1. When sodium loses this 1, it will have a formula of Na positive, and the ionic configuration is 2.8 after it loses the 1. This one will become K positive, and minus this one that it shall lose, it will have 2.8.8. If you check on these ionic configurations, this one looks like that one for helium, that we said that helium is already stable with a maximum number of 2 electrons in its only 1 energy level, and the kind of stability that it has is the one that is known as a duplet configuration. It is one type of the stable configurations that we have. These two have 8 in the outermost energy level, and when they are stable with 8 in the outermost energy level, they have the other type of a stable configuration that we call an octet configuration. So for this one, sodium, this configuration that is already stable looks like that one of neon. This one looks like that one of argon, because it is the next the next stable noble gas that is next to them. So beryllium will become beryllium with 2 positive, and after it loses the 2, it will again go back to 2 like that one of helium. This is the ionic arrangement. When you go to magnesium, it has Mg 2 positive. Once it loses these 2, it will end up with 2.8. Calcium, it loses the 2, so become Ca2 positive with 2.8.8. So this one like that one of helium, this one like that of neon. I can already hear you saying that. Calcium becomes stable with an ionic arrangement like that one of argon. Very good. So we go on to this one. So for your assignment, determine what kind of ions that will be formed once boron and aluminium, each one loses 3 electrons from the outermost energy level. Remember, the lessons that we have, a good number of them up to this far, are all to assist you to know the 2 major ways that you can use when you are determining the valency of any given element. So I hope you continue writing good notes, and in case you have any question, make sure that you ask it in the comment section. Remember, all these we are doing to back up one of the lessons that we did earlier on about the periodic table, because the questions that will follow will include such questions like writing chemical equations using some elements that are provided in on a periodic table, like the one that we had earlier on. So this is the backup information that any given student should have, so as to be in a position to answer questions in the periodic table.